So Tekla itself, we get involved in all kinds of projects, from sculpture work, offshore refineries, offshore platforms, bridge work, typical kind of industrial buildings. So here's our Tekla world. So just some of the kind of projects we get involved in on a daily, day-to-day basis. So we're involved in your typical sort of structural steel, so shopping malls, warehouses, supermarkets, that kind of thing. Bridge work, transmission towers, which are very, very specialized structures. I don't know if anyone here does transmission towers, but an industry by itself, actually, that. We've got some really nice tools for transmission towers. Also, we're heavily involved in the offshore industry, and also in the sort of wind turbines, that kind of thing. So, but we talked about Tekla. We had a lot of presentations, a lot of theory about, you know, well, what is Tekla? Well, Tekla is a software that a detailer uses to create a three-dimensional model. This model is a prototype of the structure. So it's really the complete structure within the computer. So as a detailer, all I do is I create that one-to-one scale prototype. I don't worry about material lists. I don't worry about drawings. I don't worry about anything else. All I do is create that model. Everything that's required for manufacturing then is automatically created by the software. So you don't need one guy for listing, you don't need one guy for detailing, one guy for concrete, one guy for planning and scheduling. It can all be done within one central model. So excuse me while I sit them down. I'm just going to go and just quickly flick to the software here for you. So if you're not seeing it before, this is Tekla Structures. And as you can see there, what we're doing is we're building a one-to-one scale prototype. I'm just jumping into this model here to show you it. Everything in Tekla is an object. By the way, even though this is a large structure, you can see how easily I can navigate it. So as explained earlier, it doesn't matter how big the project is, it can be handled within the software. If I click on this software here, this stiffener, sorry, you can see it's a 30mm stiffener. I can click on that, make it 30. So you can quickly change the size on screen. Let me just change that to something more ridiculous, like 130, which is stupid. Just show you the change on screen. So as a detailer, what I'm doing is I'm sitting there and creating this object. And then at the moment, that's 215 wide. Let's make that 115. So click and make it different size. So then, okay, I'm going to make this 30 by 115. So you're just putting the object in there and changing it to match what's required from the drawings. Then from that model, everything such as, let's say, shop drawings are automatically generated by the software. So have a look at here, just window in. These drawings are in color, by the way. So it then creates for you fully detailed drawings of all the pieces. The drawings it creates are just drawings. You can pick them up and modify them like any other CAD drawing. You can print them out to PDF. You can export them to AutoCAD if you wish. You also get a full automatic bill of materials with weight, surface area. And the weights and surface area can be net or gross, depending on how you like to calculate that. Again, all the fittings, everything comes on there. The drawing borders, you can bring in your standard company drawing borders within there, etc., etc. So we're creating those. As well as that, then we're creating material lists from that structure. Now, a material list can be anything. It can be an Access database, it can be an Excel spreadsheet, it can be a barcode list. So let's take a look first of all at the material list. This is an Excel spreadsheet I'm going to create. So that's an Excel spreadsheet of the model data, or the part of that model. Let's take a look at the part list, show that on screen. Again, that's a part list, so that's a list of every individual part on that project. So again, size, weight, grade, length, total surface area, not calculated by anyone, calculated by the software. But a material list can also be like a barcode. So a material list for us can be anything, so it can also be a barcode list. So anything that's required for manufacture is created from that model. So again, as a detailer, what I'm doing is I'm creating that one-to-one scale prototype, and that's my job. Really, that's what I do on a day-to-day basis, and I know I've done it for a living. So what you do is you create that model, and then you're feeding everything in the production center. Okay, so there's my detailer in my structural world. Now, you've had a lot of examples of what we get involved in. Let me just take some more up-to-date ones. For the recent World Cup in Brazil, I think 90% of the stadiums were done on Tekla. So here's an example of a football stadium done in Brazil for the World Cup. So stadiums. Highway bridges, a lot of bridge work going off at the moment. Unfortunately, coming in, it's all in concrete. But for example, in the US, a lot of bridges being redone in the US and worldwide as well. Bridges can be architectural bridges or your standard highway bridges. Both have their complexities. If you've worked in bridges, you know they're very complex, swept 3D geometry. They're not simple, straight elements. So making those in Tekla is what makes the 3D software worth its salt. Architectural styles of buildings, such as the Sky Park in Singapore. I'll get into some really fancy things now. The Art Museum in Singapore as well. My favorite slide, I like this one, is the super tree structures that were done in Singapore as well. How you would draw that in 2D is, well, it's impossible. Because it's a 3D software, it allows you to model that and then create the drawings from it. Not worrying about the mathematics and the connections and the collisions. That's all done for you. We also have, we were always able to do transmission towers, but we've now got a new set of tools to automate transmission tower detailing much more as well. So all the different styles and types of transmission towers done within Tekla. In the offshore world, offshore itself goes into many little sub-segments. So you've got floating production systems, you've got FSPOs, you've got top decks, you've got accommodation, all that kind of stuff. So anything to do with offshore, we're also heavily involved in that. Part of offshore, of course, is wind turbines. What I want to make clear, first of all, is we're not a mechanical package. So the motor and the turbine blades would not be done on Tekla. What we're doing is we're doing the structural basis of these platforms. So anything structural, that's what we do within Tekla. And I don't know if you've ever seen one of these wind turbines. They are absolutely huge. Okay, so Tekla then, for modeling and detailing structures, it's not just used by the detail, it's used by engineers, detailers, fabricators, schedulers, anyone that's working on the project can get the information that they require. I remember when I first started with these 3D softwares, we used to have detailers and then we used to have checkers. So then the checker would check every single workshop drawing and with his yellow crayon, not remember, in his red crayon, and check every drawing. When we came to the 3D model, the checker was no longer wanted because the model, if the model's correct, the drawings were correct. So all the guy had to do was check the model, check your sort of basic connections, check everything was okay, and then everything was fine from that. And that took a lot of sort of education on behalf of the company to accept that you no longer wanted somebody to check every single workshop drawing. Quite a change in mindset, actually. Tekla can do, as you can see there, can handle large and complex projects, can handle any type of profile, so elliptical, beams, angles, pipes. We've just been doing a lot recently on curtain walling, which is the complex aluminium structures, aluminium shapes, so they're all within Tekla as well now. And we can integrate, as we briefly touched upon earlier, if you're using analysis and design software, or if you're using a plant modeling software, you've got an engineer that's already building up a project. We can take that project from that software, put it into Tekla, and you get the 3D model based on the engineering model automatically. So you don't have to redetail it, that comes through. What that is, it's just a point-to-point model, and then we go ahead and connect it. So that's how we use that model. We can also start in Tekla, build a model very quickly, and then pass that out to the analysis package. So it works both ways, or the plant modeling package. So STAAD, GT Strudel, SAP 2000, wherever you happen to have, all the major software packages are covered by this, Midas, etc., etc. The clever thing about the software is it's multi-user. So that I can have my model here on my computer, I can have several detailers working on the concrete, several detailers working on the steel, somebody doing the scheduling, and they're all working on the same model at the same time. These can even be in different offices. So you're all working at the same model, and you will see that any changes I make, so everyone's working at one real model at the same time, not an export-import, but a real model, real access. That's a really important part, and it makes kind of Tekla unique in how it works. Again then, so basic structural, bridge work, offshore, miscellaneous, metal frame, plate work, pylons, all developments, all that kind of stuff. I've shown you here a lot of big glamorous projects, well, because that's what I do, because I'm presenting, so I'm going to show you all the best glamorous projects I can. But we have a lot of, I would say, 90% of our clients are one-man, two-man detailing officers who do, let's say, staircases, who do work for a small fabricator, so simple portal frame, that kind of thing. So we have every side of the spectrum. We have one-man detailing officers, and we also have detailing companies like Protheus who run 200 licenses. Okay, so again, just talking quickly about integration, then I'm not going to dwell on this too much, but it just means that you can bring your model in from any other software, so STAAD, SACS, whatever it happens to be, bring it into Tekla, import and export out. So you can start your model in, let's say, plant modeling software, pass it into Tekla, detail it, pass it backwards and forwards. So you can pass it from one software to the other backwards. And very easily. There's not a lot of work required to do that. So again, integrating, taking a model from Intergraph, Smart 3D into Tekla. Taking a model from PDMS, which in the offshore industry is one of the de facto standards. Taking that into Tekla backwards and forwards. So again, just a quick slide. Take it from the other software into Tekla, detail it, pass it back into the other software. So again, it transfers into all these. If you want to take that model into SketchUp, for example, take it into SketchUp. If you want to take the model into 3D Studio Max for photorealistic rendering, all these options, just take them out. They're all within Tekla. I won't spend too much time on that. Okay, so you got your model. What does it actually create for you as a fabricator or an engineering office? Well, it creates your material listings, as I just showed you. Again, Excel spreadsheets in any format you want, barcodes. If you've got systems already in place that require a certain kind of material list to fit into it, then you can just create one in Tekla that matches it. I'm guaranteed it'll just match it up. So it can fit into existing standards already. Then, of course, you've got workshop drawings. So these are what we call assembly drawings, but we also create drawings of all the small parts as well. So all the small parts are created, all the pieces. So, for example, that's the drawing that it creates to create these pieces in the workshop. Again, then, your engineering drawings, so your sections through, plans, elevations, these are all driven by the software. I don't draw any of this. This is automatically drawn by the system for me. As I change the model or I get new revisions, the drawings update themselves. I never have to redraw them. Let me show you all this live anyway. So again, you get the sort of assembly drawings showing how that gets together. And these are real models and real parts, by the way. Okay, then of course we can link it down to other softwares, so workshop management softwares. These softwares then manage your factory. So it tells you then, which machine is best for these pieces. So it does the routing through the factory. It tells you how much time it's going to take to do them. It does bar nesting. It does plate nesting. It takes care of all the management in the actual factory floor. So what you're doing then is then passing these parts from Tekla down to CNC machines. We link to any CNC machine. Okay, I've got a Fichette picture there, but it could be Peddinghaus, it could be Wagner, it could be Wortmann. Doesn't matter. You can link to any of these. Okay, and again, once it's there, then you can see you get all the markup of the pieces. You can't quite see this. But traditionally what happened when you passed a piece down to the factory floor, the machines just cut and drilled the piece of steel. Now these machines cut and they actually mark how the pieces fit together. So it actually changes the piece of steel into a drawing. So it shows the fact that the assembler, he gets the pieces and it actually quite simply shows how these pieces go together. So it doesn't need to refer to a drawing anymore. So, no measuring, no nothing. It's all done by the machine. So these parts here, you can see that. In fact, I'm going to quickly just show you something, actually. Sorry for jumping in and out of the model here. This model, for example, I've created the CNC files. So if I show you here, this is what the actual software, this is what the machine will create. This is a free viewer for viewing the workshop floor files. You can see there, look, that what it does is it just doesn't create the plate. It does all the markup of how the pieces fit together. And you can see, look, it tells what plate that is that fits to there. So actually then, that plate, you don't need a drawing for it because the actual plate itself is the drawing. And that's the latest sort of next generation of these machines. The machine itself, I'll just show you this very quickly, looks like this. So this machine has got a tool which then marks the steel to show, scribes it basically. So it does the scribing, which a man would do manually, it does for you. So then it shows you how the pieces of steel go together. It's like a pen plotter on a piece of steel, actually. Okay, so that's that. Once the pieces are within the software, then they can optimize those bars for bar nesting. Now, if you've already got a bar nesting software, we can integrate to that bar nesting software. It doesn't matter whether it's Strumis, FabTrol, it doesn't matter to us. We can link into it and do that for you. Then there's also the plate nesting. If you have a plate nesting software, we can link as well to the plate nesting. So we can take, you don't need to do any work, just take the elements from Tekla, it'll drop into your existing plate nesting system. And this then will do optimization of plates, again it does the layout, marking, all that kind of stuff, and finally links down to your machine. Once it's within, the higher level softwares can then do a time calculation. So then look all the pieces from Tekla and say, oh, it's going to take my factory 4 days, 4 hours, and 5 minutes to make these pieces. And if a machine is, let's say, out of commission, it will then take 5 days. So it will actually recalculate it for you. And that's based on actual holes, so it knows a 22 diameter hole takes longer to drill than an 18 diameter hole. So even down to milliseconds, it calculates it for you. Okay, and then what you're doing eventually is then it's working out how to feed those pieces through your factory. Now, not everyone has an automated factory, I'm aware of that. But it doesn't matter if you've got 1 machine or 20 machines. These softwares then tell the factory how to work. But all the information ultimately comes down from the Tekla model. As it's going through these machines, you can then set it up so the Tekla model will reflect the production status. So it'll say, okay, those pieces have been finished, now these pieces have been done. So as it goes through the factory, it will then tell you on the Tekla model where we are in production. So real-time feedback from the actual factory floor, if you want to be that precise, of course. There's not many working to this level at the moment, but you can actually work to that level. It's not just for beams and angles and plates. You've also got complex pipe-to-pipe connections, especially in offshore. So we link down, there are specialized machines which do then the sort of three-dimensional cutting of the pipes. Beautiful machines. We put the elements in Tekla, apply the connection, tell it what the weld preparation is, so you don't need those wraparound templates anymore that you used to create. By the way, we can still create them if you want, but you don't need them if necessary. So these are the machines. You can see what it creates. In one cut, it does actually the beveling, coping information. So no manual preparation required whatsoever. And that's going to be a final product. Again, I'll just show you what that machine looks like. So these machines then look like this. So that's a pipe cutting machine. What I'm trying to say here is that all the instructions to cut that pipe come from the Tekla model. So there's nobody programming this, it's all straight down. But if you look at the head of that cutting, it does the three-dimensional beveling at the same time. Very complex mathematics going on. It cuts that to shape. And you can see then as that fits together, then there's no grinding, preparation required. It's done in one cut. So that's the level of complexity you can link down to it if you've got that machine, of course. So that's the sort of pipe cutting profiles there as well. Welding robotics. This is not really happening too much at the moment. Welding robotics at the moment is mainly seen in shipbuilding. But it's beginning to find its way now into structural steel. We do have a company already that makes welding robots that link to Tekla. So what you do is you've got your Tekla model here. What we're doing as well in Tekla is we're actually not just modeling plates and cuts and bolts, we're also modeling the welds themselves. So it's a 6mm fillet weld, it puts it in there, and it's 100mm long, it puts it in. And then we can say, want a material list for that, what's the volume of welds required, and then we can link it down to the machine. The machines look like this, sort of automated centers. Again, so you've got the welds in Tekla. We've got new functionality that came out in version 19 and version 20, which allow us to model real welds, real weld weights, absolutely accurately, complete with all preparations and everything automatic. Beautiful functionality. And again, you can color code them, get the different ones here. Typical kind of Tekla stuff. Again, get the lists for your sort of surface areas, weights, welds, volumes of welds for the project. So then what you do is you've got those in there, then you can export it out like any other export on Tekla, export it. Creates just simple sort of XML file that then we take to the machine. And then we take that straight out then to the machine, which tells it how to weld. Rather than me talk about that, it's easy to show a video. So then this is created by the company themselves. Bit of an introduction first of all, just showing a bridge for some reason. So this is just trying to explain our Tekla virtual world, where people are working on the project and, you know, building it up, usual kind of thing. It's about taking that information from there and passing it to the robot. So send it down to production, these pieces. It's quite glamorous here, doesn't it? It's not quite like that. So then you've got your detailing model. So there it is, that's your Tekla model there. You export the data out. If you've got a welding robot, you can export it out, import it to their software, and then you get the same piece in their software, and that's representation of the welds. And then what you do is you send that down to the machine on the workshop. Then the machine on the workshop, you've got the little simulation that shows how it's going to operate when it gets there. And then down to the actual workshop itself. So you can see you've got a guy there that's driving this welding center. And then the welding robot. Fantastic, that, isn't it? I showed my brother this, who's a welder, but he wasn't too impressed about it at all. But then the welding robot welds exactly matching those welds that are actually in the Tekla model. The clever thing is, if the assemblers put that together wrong, it actually scans it first with the laser and checks to the Tekla model it's correct. It's been made correct. So it actually checks it as well, so it's a checking facility. And that's how it runs it through. As I said there, at the moment, I can't tell you a single steel fabricator that's using that. But they are pushing into that side of the industry now. That's where they're looking at, in the structural steel side of things. Mainly using shipbuilding, where we've got lots of standard plates welded to the hull, where they're going to weld those together. Okay, so again, that's your final piece. Laser scanning, quite a hot topic at the moment as well. Laser scanning has been around for actually quite a long time now. But I don't know if you've ever used a laser scanner, or you've had access to a laser scanning model. If you want to know how much a laser scanning unit is, by the way, it's £34,000, English pounds. So not a cheap unit. What they do is they create a sort of ghost image of the structure. It doesn't build a solid model, it builds an image that's actually created from millions and millions of little dots. It's called a point cloud. And then what it is, it's like a ghost. It's not a solid object. So what you have to do then to use it within Tekla is you have to convert it to a DWG. There's softwares then that convert it so you can take that model into Tekla. Okay, so if you ever get involved in point cloud manipulation or you get a laser scan object, well, you can do something with it. I've got a whole presentation on this, so I'm not going to cover it now, but if you want, I can leave the presentation with you. Definitely good for sort of rework of projects like offshore, where you're actually looking at an existing project, you need to add to it or do refurbishment. Beautiful stuff. Oh yeah, I forgot about this. You can also, if you want as well, you can take the model from Tekla and put it into its real world location in Google Earth. And would you believe, I've got an example ready for you. So in Google Earth, you can actually take your Tekla project. I'm really bad at navigating Google Earth, by the way, so bear with me here. So you can see, if I just zoom in, you can see then that that's my Tekla model there in Google Earth. So you place it into its real location, and they can put it exactly where it is on Earth. I told you I'm bad at navigating this, and then you can spin around and show it where it is. So I've got several projects here. I've got then, let's say, an offshore platform, which is actually the other side of the planet. So then that's my offshore platform, which is in Norway. So you can have all your projects that's going on around the world or in India, and you can put them into Google Earth and jump and view them where they are. And you can keep them updated. It's not an automatic process. You'd have to manually put them on there. But once they're there, you can actually save them and use them. Like I say, I'm really lousy at navigating this. A lot of the world is mapped in 3D as well, so you can put it where you want. I've got a really bad example here, which I've put in a totally wrong location, so I'll show you this. This is another one in Norway. which was with Caverna Offshore. So this one I placed in the harbour, but there you go. But you can see it's floating in space. I put it at the wrong location. But you can see, look, a lot of the world is actually mapped in 3D. So it's great for taking your Tekla model and putting it into its real location, where it is, having them there. Sales tool, whatever, just something you can do. And it's just, for us, it's just one-click export as well. Okay, we also have, which we didn't really touch upon too much, the guys, we've also got mobile applications where you can now take the Tekla model and put it onto your iPhone and sort of zoom in and out and navigate and interrogate pieces on your iPhone as well. Which, bear with me, I've got it here. You can't see it here, but for example, I'm sure the guys will show you. You can put it on your phone, you can take the Tekla model, put it on your iPad, iPhone, look around it. That's our mobile application. We have two versions, a free version, which is kind of very limited, and there's a paid version which allows you to access it on the cloud and all kinds of things. We also have Tekla BIM site, which is like it's our free software, but it's a desktop application. So it allows you to share the model with people that don't have Tekla, but you know, they can share it on sort of like a Windows-based platform. Okay, you had lots of examples from the other guys of glamorous projects, so I'm not going to stop here. I'm going to do exactly the same as well. So just a few examples of some projects done on Tekla, steel kind of projects. So again, a sort of good cross-section of the types of projects we get involved with. You've seen a couple of these already, so I'll skip those. The Olympic Stadium in Russia with the complex curved roof. That was a nice one that was done in Tekla. Way over budget, by the way, by the Russian government, though, not Tekla. Sort of oil refineries, William Hare, which is a big client in India as well, actually. Offshore platforms. This one was done in India. Indonesia, offshore platform. Topsides, where these are the topsides that fit on the deck. Everton Football Park. Lots of stadiums done recently. Olympic Stadium. I've just shown you this one anyway, the Brazil Stadium. Again, more refineries, a new train station in Africa, Airbus factory in the UK. So your general day-to-day work, anything really that's a structural model is done, can be done within Tekla.